milling machine rotates the cutter mounted on the arbor of the machine and at the same time automatically feed the work in the required direction. The milling machine may be classified in several forms, but the choice of any particular machine is determined primarily by the size of the workpiece. Milling machines are made in a variety of types and sizes. According to general design, the distinctive type of milling machines are discussed here. First being the column and knee type milling machine, under which hand milling machine comes. Horizontal, universal and vertical milling machine comes. Then we have planar milling machine, fixed bed type milling machine, under which simplex, duplex and triplex milling machine comes. Then we have machining center machines. And last but not the least, some special type of milling machines are also there, under which rotary table, planetary, profiling, duplicating, pantograph, continuous, drum, and profiling and tracer control milling machine comes. Out of all this classification of milling machine, we are going to discuss about the column and knee type of milling machine. This particular figure here shows a simple column and knee type milling machine. It is most commonly used milling machine which is used in any shop work. In this type of milling machine, the table is mounted on the knee casting, which in turn is mounted on the vertical slides of the main column. The knee is vertically adjustable on the column so that the table can be moved up and down to accommodate work of various heights. The column and knee type milling machine are classified on the basis of various methods of supplying power to the cable, different movement of the table and different axes of rotation of the main spindle. The various parts that this column and knee type milling machine comprise are base, column, saddle, table, elevating screw, knee, knee elevating handle, cross feed handle, front brace, arbor support, arbor itself, overhanging arm, cutter, cone pulley and telescopic feed shaft. Now let's discuss all these parts in detail. We are going to discuss only the major parts. First is the base. It is a foundation member of all the other parts which rest upon it. It carries the column at its one end. In some machines, the base is hollow and serves as a reservoir for cutting fluid. Next we have the column. The column is the main supporting member which is mounted vertically on the base. It is box-shaped, heavily ribbed inside and houses all the driving mechanism for the spindle and table feed. The front vertical face of the column is accurately machined and is provided with dovetail guideways for supporting the knee. And hence we have the knee. The knee is a rigid grey iron casting which slides up and down on the vertical base of the column face. An elevating screw mounted on the base is used to adjust the height of the knee, and it also supports the knee. The knee houses the feed mechanism of the table and controls the overall operation. Then we have the saddle. The saddle is placed on the top of the knee and it slides on guideways set exactly at 90 degrees to the column face. Then we have the table. The table rests on ways on the saddle and travels longitudinally. A lead screw under the table engages a nut on the saddle to move the table horizontally by hand or power. In universal machines, the table may also be swiveled horizontally. For this same purpose, the table is mounted on a circular base. Then we have the overhanging arm. It is mounted on the top of the column, which extends beyond the column face and serves as a bearing support for the other end of the arbor. And then we have the front brace. It is an extra support which is fitted between the knee and the overarm. Then we have spindle. Spindle is situated in the upper part of the column and receives power from the motor through belt and gears. This power is then transmitted to the arbor. And this arbor is like an extension of the machine spindle on which milling cutters are securely mounted and rotated. The arbor are made with taper shanks for proper alignment with the machine spindles and have taper holes at their nose. The drawer bolt is used for managing for locking the arbor with the spindle and the whole assembly. Typically, the arbor assembly consists of these components: spindle, spacing collars, bearing bush, cutter, draw bolt, lock nut, key block, and set screw.